classroom on this dark evening, although I am illuminated at the moment by these cool bulb things, which I have to be very careful of this one. This one has a shattered chunk out of it, so I'll make sure not to touch that shattered end. But in any case, it was time for a little live stream here in the classroom, and I can actually brighten things with the computer screen. I just wanted a dramatic intro, forgive me. But we're back in the combo classroom, and it's time that I'm beginning a new grade. Each grade of combo class sort of corresponding with a era of my life measured in the time span it takes me to make what I consider like a season of my strange educational show on my main combo class channel, being 36 episodes per grade and whatever bonus content appears here. And we're at the time where the grade shift is occurring, where grade -2 has wrapped up, and we can consider this sort of like an early for class for grade -3. Grade -3 before the opening bell has rung, where I want to discuss the number -3 and its good friend +3, some interesting traits about these numbers, as well as some clues of what we might see in grade -3. For example, you may notice that the old burnt lab coat is hanging here, and I'm wearing a new lab coat. In fact, in grade -3, you can expect to see two lab coats. This one I'm wearing is actually a thinner, slightly too big for me one that I got for cheaper that will be somewhat my travel lab coat, because it's good to have a thinner one for adventures that's easier to pack, and a slightly cozier one for the classroom. So I actually will have this adventure coat as well as my typical lab coat. We are expanding the arsenal, and I do keep the old ones. Someday they will come in handy too. But we're at the beginning of the clean cycle, so place your bets on how long it takes before we get the first marker stain or burn mark or anything like that. Now, I'm also setting up my classroom in many new ways, and we are in a strange corner on the side of the classroom. There is where it says combo class that I spray painted a while ago next to the grandfather clock. We're sitting at this different than usual angle with less of a exciting view of the classroom because I want to keep a few surprises as for things that I have set up for this new grade. For example, some new classroom supplies, including new clocks and stuff, and as much as I want to keep all the new clocks a surprise, I do have to share one of them with you because it's so cool that I can't help but share one of the clocks with you folks. So I am often on the lookout for clocks that I can find very cheap due to being in broken condition at some thrift store or used goods store or yard sale or something like that. And those are fun because it's different antique clocks that tell a story from time through their different construction and image and such. And I also like the scale of clocks. Like, it's fun to have one that is this large. Well, what about breaking some new records for largest? What about largest circular clock? We have broken the clock size. And the clock size has been broken by this used one that is, in my opinion, under one metric, the largest one we have on this channel, or in the classroom. And it is going to get a better view in the official grade -3 intro, but I needed to give you a little view of how massive this thing is for now because we have set a new record for largest circular clock around here, and there are many others that I've gotten as well that I'll be sharing in the official grade -3 intro episode. That will be coming on my combo class channel where my more polished episodes go, and I do want all of you to make sure that you have seen the grade -2 finale episode, which I put out a couple days ago on that channel, and that isn't too math-oriented for viewers who like that, but it does tell a lot of important details about my life and about behind the scenes and a lot of cool things that I would like my viewers to see, as well as some personal things. And so hopefully you've all seen that. That's linked in the description of this little prequel stream. And I will be filming the rest of the grade -3 intro episode, which will be somewhat a welcome back to the classroom and sort of a channel trailerish thing for new viewers, but also will contain some fun facts about the number -3 and 3, some of the best ones. And that's partially why I'm doing this live stream, is as I was scripting what exactly do I want to discuss about the number -3 or its friend 3 in an intro episode to that number of grade. And there were too many things to put in the intro, so the intro is just going to get a few of the top-notch favorite ones, and I want to share some extras throughout the grade, including in this stream today. So we're going to consider this a little look at why is -3 and its friend 3, why do they play such a crucial, cool role within mathematics? And of course, there's a lot more we can say, or maybe it's easier to say in the way we could, about +3 than -3. So we're going to often be using 3 as the theme of this grade, more than -3, because we're going to have to add a whole layer of extra description to convert any of my analogies about 3 into -3. Sometimes it's easier, like -3 can be seen as the difference of two numbers just as much as +3 can, because it's this one -3 hits that just as much as this one +3 hits that. And so I got to remember when I'm putting my hands up in front of the camera, it's flipped for you folks when I do my number liney things, that it's going to be flipped. Anyway, -3 will get some fun traits, but a lot of them get passed on to 3. The one I put right here on top to begin is a trait of -3 as well as 3. I put this as a less commonly known identity to the version of this. 1 times 2 times 3 equals 1 plus 2 plus 3. And is this showing up properly? I think the background's frozen, so let me make the background actually move. For some reason, I need a tech whiz on the team still. I don't know how to make it so it doesn't freeze before I start the stream. I always have to reboot this thing and cause a little portal to appear and then fix it. Anyway, this right here is a very beginning equation that many people may already know, which actually plays a crucial role in some aspects of number theory, because each of these sides has a name. Multiplying all of the whole numbers up through something is the factorial of that number. This is called 3 factorial. And adding them doesn't have as simple of a symbol, although I think it should. And that is the triangular numbers that add up to some point. 1 plus 2 plus 3. Like, imagine a triangle if you were having 1 and then 2 and then 3 and then more if you keep going with triangular numbers. Well, although they don't have as clear of analogies, it actually does work with negatives too. See here, we got -1 times -2 times -3 is -6, because we have 3 of these and a pair of them cancel out, basically leaving 1, so it's still negative. And here we have -1 plus -2 plus -3 does give us -6 as well. Now, can we even see this graphically? What? On a graph, you say? Well, actually, yes, we can. If we graph, what points? We're going to have to call 2 of the variables x and y, and then one of the variables for this. We're basically doing a times b times c equals a plus b plus c, but we don't want them all to need sliders. We want to use the graph somehow, so we're going to make these x times y times a equals x plus y plus a, and we're going to make a slider for a. And if we set a to -1, we can see that we do get an integer coordinate at -2, -3 precisely. And we get an integer coordinate at -3, -2. And we could do the same thing if we set it to -3. Then we would have -1 and -2 would be our integer coordinate pairs. And so we can see a lot of cool stuff on graphs too. And the graph is going to come in handy for a second because I want to use it to show how threes also sometimes are when things get weird or interesting. And although I want to say it's because they're three-even, multiples of 3, three-even numbers have many cool traits we'll look at this grade, but a lot of the traits on graphs where threes make it go crazy do also relate more so to the fact that 3 is the first sort of non-trivial odd number. If you're doing something multiplicative, 1 can be kind of trivial. Multiplicatively, 3 could be considered like the first non-trivial of the odds in a way. And so we could, for example, if we want to see 3 do something weird, I mean, a simple example is if we have y equals x to the power of a, and if we're at 1, we just get a line. If we're at 2, we get the classic parabola that you're familiar with. But if we go up to 3, we get a different type of symmetry. Now, instead of being symmetrical across an axis, it's symmetrical by rotation. Totally changes the type of symmetry. And this could also be messed with further levels, of course. If we do like funny stuff with it here, we'll notice different patterns for 2 than with 3. And 3 is sort of the first of this family, like 1 would just be the normal-ish sine function, that starts doing wacky stuff. Now with this sine guy here, you know, we can also note that if I were to say we're doing sine of 3x, we're like, whoa, each of these half cycles hits kind of close to 1. And you want to know why? You want to know how much more than 1 it hits by? The amount more than 1 that it hits... Wait, I want to be on 0. It won't let me go to 0. But about... Oh, there. Pi thirds. They even knew. Sometimes they're wrong on this because there's like an approximation that they think is something, and it'll think something is... You could put like a really good approximation for pi, and it might think it's exact. But this at least means it's really close. And it is exact in this case. That the amount more than 1 was the ratio between pi and 3, essentially, because I tripled it, and the sine function works in multiples of pi. And the reason it went close to 1 is because 3 is really close to pi. You know what else 3 is really close to? E. The other, like, most classic non-integer mathematical constant. 3 is also close to the golden ratio's maybe arguably best friend. It sort of has 2 best friends. One is its reciprocal. One is the number that is it squared is also it plus 1. So that number that is both 1 more than the golden ratio and also the golden ratio squared. And with knowing that even exists in that relationship, you can basically define the golden ratio. That is also closest to 3 if you round them. So a lot of mathematical constants are weirdly close to 3. And so 3 gets sometimes superpowers just by being close to those fellas. And on a graph, one more thing I would like to see. And someone says prequel means that it comes out after it happens, but happens before. I know it typically means that, but I don't know what I might end up titling this stream based on what we explore. I called the stream now prequel live stream because I was just looking for words that meant like a preface to something. And I was almost going to call it like preface to grade -3, but that didn't seem to roll off the tongue as well as a video title here for a live stream. So I ended up calling it a prequel. In this case, I went back in time to make the prequel. But I do get your point. I'm not sure word-wise if that's always implied in the definition. Let's see how they commonly define prequel, maybe. Just out of curiosity. Definition of prequel. And just to make sure this is all good, I'm just going to search it here on my own. And because sometimes when I've searched things on Google, it's shown like estimates of my address to be like, are you looking for results in this zone? And it's hard to turn that off. Luckily, they have not given precise ones, so any spies will probably be led off the trail by that happening, but still. A prequel is a story or movie containing events that precede those of an existing work. So I guess, yeah, in the definition, prequels are supposed to come out before. So Poochie Vert in the comments is correct. Perhaps I will go back and rename it Preface like I was thinking. We'll see. In any sense, for now, we'll imagine I went back in time to make this. And here someone says, I look completely different after the haircut. Now, I've actually gone through looking somewhat like this. This is the third time for grade -3 because at the very beginning of combo class, I didn't look that different than this. Like, as a reminder, I mean, actually, the main difference is I've gained a little weight. And then, unfortunately, so I had a small lab coat that fit well because small stuff works well on me. I'm not a huge guy. And I'm like on the shorter end of a little under average for height in America. It skews in different areas. But so a small lab coat normally fit me. So I got a medium one here because I was like, okay, I've gained a little weight. I do intend on losing that and getting into extra good shape this grade. But I got a medium lab coat, and here, luckily, it's just going to be like my travel coat, but it is a bit too big. I shouldn't have gone for that. Anyway, as far as the haircut, I've actually looked kind of like this a few times. Oh no, what have I done? Oh no, what have I done? I lost the... It's like so far on the edge, I can't get it. Can't like grab the video anymore. It's... What? What am I supposed to do here? Okay, there we go. No, okay, almost there we go. I got it back. But there, okay, there we go. Did I flip it now or something? Is that right? Yeah, that's okay. Anyway, I've looked like this a few times because before this was the beginning of grade -2. So not that different. And then maybe a little longer than it is now. I cut it myself and then went to a barber to tidy it up. So they had to work with what they were given. And I was like, okay, whatever spot I accidentally cut it shortest, make it that long. But then here's the beginning of grade -1. So you see, it's actually a few times the hair has recurred. Oh my God, I'm just trying to move it. I'm not trying to do anything crazy, program. Okay. Now, a few times it has looked like this, and it probably will continue the pattern in grade -3. No promises, but it'll probably get long again. The lab coat will probably get dirty again. We will see the processes continue, but it is a radical shift. A lot of YouTubers care about having like a consistent brand. I always got to look the same. I'm not like that. I want to ride a little bit of a cycle. We got to have different phases, and they are cyclical in a strange way with stuff like hair where it grows out like the hours ticking up on a clock, and then bam, the hours got small again. So thank you to anyone with random comments. And somebody asked, what's the best, Chevrolet or Ford? I'm not really a car guy in terms of caring about that stuff that much, so I'm not your guy to answer that question. I'm sorry. Now, going back to our graphs for now, one more thing I want to show on Desmos is I showed, okay, 3 is sometimes the point where things get wacky, and maybe we'll look more at that, but an example is being the first non-trivial odd if we're raising things to powers. What about 3 being the first time where things grow? Now, let's look at the factorial function. Now, this is using the in-between values that are defined by what's called the gamma function. So ignore the in-between values. Let's imagine we're just looking at the integer values. So 1 is like 1 times 1, or it's actually just like 1 on its own. 2 is like 1 times 2. 3 is like 1 times 2 times 3, and etc. So we can see it's kind of flying up, but would we say it explodes at a certain point? Would we say that's between 2 and 3, 3 and 4? A little ambiguous. So what if we want to find out where it explodes? by stacking some of these factorials. So what if I'm like x factorial, then another? I can't put them in a row. I'm not sure how the program's going to read that, but at least mathematically, if they're straight back to back, it actually means a different thing called a double factorial if there's two of them, which is not just doing the factorial twice. But so we're putting parentheses to be safe with the program. Okay, that made it a little different. Let's stack another one and another one. And in this zone we're looking at with these integers, we're like, whoa. So here got pretty flat, but didn't stretch anywhere surprising. Here got kind of compressed, but it still only gets us to 2, because 2 factorial, then that factorial, then that factorial, then that factorial, stuck at 2. 3, if we iterate taking the factorial of it, goes bigger and bigger. If we iterate this toward infinity, 3 will fly toward infinity, 2 won't. So sometimes, even though 2 would seem like the first whole number that implies growth in certain ways, if not 1, sometimes it's 3. Now, there's a lot I have to say about 3s, and for now, I think what we'll look at are a few equations related to 3s. And for example, we pulled up these classics, but using the numbers 1, 2, and 3. Let's just do a little reminder of some classic identities right here. So 1 plus 2 gets us 3. Then 1 plus 2 plus 3 gets us 1 times 2 times 3. They equal out right there. The crazy thing too is that if we square this number 6 that we've created from either the third triangular or third factorial, that 36 is also a triangular number. It's if we add up the first 8 numbers. So we could also say this is equal to adding up the first 8 numbers and then taking the square root. So that's, a lot of ways we can get to this 6 right here. Now, if we play with the 2 and 3 in different ways, what do we notice about like a number line of whole numbers going up? Well, check this out. We got our first ones, our 1s and 2s and 3s and stuff. Then 3 is sandwiched between powers of 2. It's also the only prime 1 less than a square. I'll probably show a proof for that because it's pretty quick in the official intro episode for grade -3 when I share some of my favorite of the facts about 3. Then what about after this 4 that 3 is friends with? Because it's neighbors and we got our prime under our square. In fact, here we have a prime right over a factorial, which are also nicknamed factorial primes and are notable. Factorial primes can be 1 over or under a factorial. Here we also have a prime sandwiched between powers of 2. And obviously these get further apart, so this is the only number that is sandwiched between 2 powers of 2. So what about other numbers that are neighbors in special ways? Well, here we get the sum of 2 and 3, these friends, and here we get their product. Now, these may seem a little random, the 5 and the 7. The 6 is like, okay, we've sort of gotten there a bunch of ways. But the 5 and the 7, if we counted in base 6, would have superpowers, because this would be like our 9. It would still look like a 5, but that'd be the highest digit. And this would look like 1, 1. Speaking of which, in binary, 3 is 1, 1. That actually relates to the fact that it's what's called a Mersenne prime. And that will be in one of the early grade -3 episodes where we go deeper into Mersenne primes, which is the type of prime that the newest, largest known prime ever that was discovered is of that form. We will be diving deeper into their connection with perfect numbers and how it associates with a new perfect number as well. That will be one of the early episodes of grade -3. And one of the episodes a little further in grade -3 will be about something called Fermat primes that are over 1 larger than a certain type of power of 2, 2 to the power of 2 to the power of something, all plus 1. When that's a prime, turns out to relate to which shapes you can construct with a straight edge and compass. And so Fermat primes are pretty rare. Only 5 of them are known. And you can see, based on this trait, that 3 is the only prime that is sandwiched between powers of 2. That 3 has the only possibility of being both a Mersenne prime and a Fermat prime, both of those cool types. So we'll go into the Fermat primes more later, and the Mersenne primes even sooner, because they connect with, not everyone's talking about how the new big prime number also got us a new perfect number, but that's pretty cool. And we're going to go deeper into perfect numbers. And here, as we get up to 8 and 9, here we got 2 to the power of 3 and 3 to the power of 2. And 2 to the power of 3 is the only perfect power, which is a positive integer to the power of a positive integer larger than 1. The only perfect power, one less than another perfect power. Also, you could say that this is the only perfect power, one more than another. So not only are 2 and 3 friends as the only neighboring primes, but 8 and 9 are friends, which are composed of these using exponentiation, that to the that, and that to the that, are also neighbors in a very special singular on the number line way. Although we should note that if we extend it a little further and don't make it be positive ones, using -1, 0, and 1, you can get clusters of perfect powers there as well that are neighbors, -1, 0, and 1, depending how you're defining your perfect powers. And here, these are like all the digits we use in our base, but really it should cut off a little earlier. And the fact that base 6 is the coolest gets a lot of credit from 3. 3 is the midway point there. And it is, like we said, 3 factorial and the third triangular number. But is that where it ends? No. Because 3 squared plus 4 squared is 5 squared. And this is another one. This is the simplest Pythagorean triple. The simplest right triangle with integer side lengths is this, or simplest sum of 2 squares into another. It's so efficient that the next smallest one is significantly bigger, not like 50 times bigger, but this one is just so much more efficient that the second smallest, if you count non-primitive ones that are multiples of them, under some metrics, the second smallest is doubling all this. 6 squared plus 8 squared is 10 squared. And then you get the other primitive ones. So this one's so efficient. And you know what we get here? These could each be phrased as the different ways of picking pairs of 1, 2, and 3. Picking a pair of those and adding them together. Picking 1 and 2, picking 1 and 3, and picking 2 and 3. So that's a pretty neat way of looking at it, but that's not where it ends. We get another identity that when I show this next so cool, so underrated one, you're going to want it to be the beginning of a pattern, and I'm sorry to say it's not a clear pattern that we can keep going with. But it does happen in a similar looking way for third powers. And the way, what I should have said about the -3s I wanted to note is that you could also make these negative. So it's also true, although it's harder to observe geometrically, this is also true with our -3. But this is the extra crazy part. So you know how we had them like this? So there's another really underrated identity. 3 cubed plus 4 cubed plus 5 cubed. It equals 6 cubed. And guess what? What if we're picking the numbers 1, 2, and 3? And we're wanting pairs of those again. So now I'm doing my 1 plus 2, my 1 plus 3, and my 2 plus 3 all on this side. And this is all of them. 1 plus 2 plus 3. I don't know if I've seen anyone else write this identity this way. I'm sure someone else has done it, but I've never seen this one broken down this way before, but I think that's a really cool way of breaking it down. Aren't these just majestic? Beautiful. So, this similar... No, actually on this one we can't replace it with negatives because the 3 in the exponent. It wouldn't stay if we replace these with or no, it would work because they would all flip the same way. Yeah, no, it would work. So yeah, we could replace these all with negatives because although the negative to the cube would become negative again, so would these. So often negatives and positives can be replaced when you're doing powers, but with odd powers, sometimes you got to watch out for them flipping. So these are a few of the identities that make 3 cool. I'm going to go deeper into the intro episode that like officially introduces to the grade, all that's going on and all the new clocks I got and such. On the main combo class channel, should be coming out in about a week, maybe a week and a day or two. And so I'll have some more bonus videos out before then. And in that, I will go a little deeper into some traits that 3 is the only number of related to either being one of or being a neighbor of things related to triangular numbers, primes, factorials, and so on. So if you want to think about some things on your own, maybe ponder, what way does 3 maybe have special traits related to some of these classic sequences like triangular numbers and factorials and so on? And beyond that, not just like 3 being a triangular number, but what are combinations of those? Like, for example, I mentioned 3 is the only prime number right under a square. Maybe you can find some other combinations that you may suspect are rare, because 3 has some singular qualities that only it has on the number line. Really, the most underrated 1-digit number is 6. And I don't even know what grade -6 is going to have. It's going to be crazy. But this grade, we're already going to get a lot of tastes of 6 due to some of these identities being not just 3 or not just -3, but the build up to there are plus or minus 1 and our plus or minus 2 as well. And when we look at 1s, 2s, and 3s together, whether additively or multiplicatively, we get our 6s or our -6s if we had all these negative. So, those are a few numerical traits. And thank you to people leaving random comments. Somebody noted there's a lack of fire. Well, there will probably be a little bit of fire in the official intro episode coming. And there were actually a lot of fire-related live streams I did not that long ago on this channel, cooking on campfires and such. So if you look back in the live stream history, there are plenty with fires. But most importantly, I will remind all of you, fires and much more are in the grade -2 finale episode. That is probably the longest I've ever spent editing a video because it has so many different scenes cut together quickly throughout it. And so that's an important episode to me. Make sure you've caught that. It's linked in the description if you haven't. And looking at the other channel here, somebody said Mathologer, the giggling German in Australia, posted a number theory episode yesterday about 2 + 2 = 2 × 2, and 1 + 2 + 3 = 1 × 2 × 3, and other such sequences. And yes, I was so honored and proud that I went on that video and I was like, I made a video about this topic, and we went into different details. We didn't discuss exactly the same thing. So, and I never would even feel like bummed out if I had made a topic and then Mathologer made a video, because he always makes great videos. If there's a good topic, I am happy when he covers it. And so he did go into different things that I went into, so it's worth watching both of those. But I was so honored when I looked down in the comments and someone mentioned that Combo Class made a video on this before, to even just be in the comments on some of those great math channels. Oh, what an honor. And that is good timing that for all of these identities we're talking about, that Mathologer just posted a new one about related to not the ones I've said, but related to a particular pattern that I covered in the past that does include the positive one of these. 1 + 2 + 3 is 1 × 2 × 3, but a different sort of family where the next thing in it can be things like 1 + 1 + 2 + 4 = 1 × 1 × 2 × 4. So you can find a video on the Combo Class channel I've made that has the positive version of this in the thumbnail if you want to see that. Also, Mathologer has done some other videos that relate to that in the past. There's one that shows how this relates to triangles. And, even if it's probably not like good for the algorithm or whatever, for me to recommend folks to watch other channels' videos, I can't help it if they're great videos. And I do recommend sometimes watching the Mathologer videos that relate to how this connects to the right triangle identity. This is basically the right triangle identity. Why it breaks down to 1s, 2s, and 3s. How that connects to the positive version of this. And because the 3-4-5 triangle's majestic. The 3-4-5 triangle has so many cool things going on in it. And at some point, there will be an episode just about that triangle that I will make, because there's so much to say about it. And there will also probably be in this grade, because 3 is the amount of sides on a triangle, we'll probably have an episode just about Triangle Hall of Fame, the coolest triangles ever, because we got to shout out all the cool triangles. There's ones called golden triangles of a few types. You got your 3-4-5 triangle. You got your 30-60-90s. You got your right isosceles triangles, also known as your 45-45-90s. But you also got weirder ones, triangles that deserve more credit. And so we'll do a Triangle Hall of Fame episode sometime, because triangles are in some ways, you could consider the after line segments the next simplest shape. And another way of looking at it, I could argue circles being the simplest, but to even be compared to circles is an honor. So triangles are, they're powerful when we're even having a thought about, is it triangles or circles that are simpler in this way? So triangles everywhere. Every polygon is just made up of a bunch of triangles. With triangles, you can do it all. And so triangles will show up a lot in this grade. And the thing I'm most excited about doing with triangles that I know will be in the grade is going to relate to the connection of 2 different triangles. It's something in math I don't know which of you have ever heard about or not, of which of these. But there's Pascal's triangle made up of numbers that is in a way of looking at triangular numbers, but it hides many other patterns as well. And then there's this fractal called Sierpinski's triangle or Sierpinski's gasket. And there's a number theory thing involving modular arithmetic where these concepts align. And I'm really excited to make that episode. That'll be one of the early ones in this grade on the Combo Class channel. Will be about a way of having Pascal's triangle and this fractal triangle show up together as one thing. So that's super cool. There's triangles of numbers we can't forget about as well, because Pascal's triangle will come up in at least one episode this grade, probably more. And I will just do a whole run through of the cool patterns in it the first time I put it in an official episode as well, because it's a really cool triangle of numbers. And triangles in general, there's a lot to say about. And also, Bjorn Larson notes that the 3-4-5 perfect Pythagorean right triangle has area of 6. Yep, that's another magical appearance of 6's conjunction with 1s, 2s, and 3s. And someone else is noting a 3 blue 1 brown new video on 4D thinking. I haven't seen that one yet, although I saw it pop up. I am excited to see that at some point. That's another great channel. And Bjorn Larson notes that circles and triangles have a lot in common, because any triangle that's not what you'd call a degenerate triangle. I'm not the one who made the name roasting the triangles. They're officially called degenerate triangles. Are the ones where all 3 points are collinear and you're like, that's not even a triangle. That's a line segment that's flat. So if it's not that, if it's a normal triangle, there's exactly one circle that passes through where the edge of the circle touches each corner. It's tangent to it. And so basically each triangle has one circumcircle exactly. They also have exactly one incircle that's tangent to the inside. And there's actually so many different types of circle and triangle that, let me see if I can find this real quick. There's this hilarious visual where So there's so many ways of defining circles related to triangles that you'd wonder, well, maybe we can say that each of these circles that has a unique definition, every triangle has one circle of this type, that the center of the circle is in a way the center of the triangle under that particular metric, because triangles otherwise don't really have a logical, this is the center, unless you make up some rule for what that means. And so you could say, well, maybe it means under this metric, it's the center of this associated circle. So there's this thing called something, I'm searching it up right now, something like the center or the something of triangle centers diagram. I'm going to look up. It's the something of triangle centers. And it's so funny because there's so many ways of defining the center of the triangle that you can see so many points, some of which are not even in the triangle. Oh man, where is this? I really want to find this. The Encyclopedia of Triangle Centers diagram. Oh, here. Yes, I got it. Okay. This is, somebody collected a lot of different ways of defining the center of a triangle. And here's an example of where they land on this triangle. Look how many of them are not even in the triangle and are defined as the center of the triangle by some metric. I mean, technically the center of an associated circle of some type, but they're calling them triangle centers. So this is one of those classic math diagrams. I don't know how classic it is in the typical lore, but to me it's classic. So that one's good. We also have a mention of Lloyd's triangle. There are many different triangles related to, what's Lloyd's triangle? I'm trying to see what that one is. I'm not seeing Lloyd's triangle online. Let me know if there's anything else I should look to find that one, because I don't know exactly that one. There's Lloyd's algorithms related to triangles. And, but let me know about that. Wade asks, do I have any slide rules? I had one at one point. I'm still reassembling all my classroom supplies to figure out which ones have gotten destroyed in the 2 grades so far. Not just by me, but sometimes by being out in the rain and stuff. And partially by me. And I don't know if the slide rule has survived the grades or where it's at the moment. But I am accumulating and collecting, and some things are going in the trash, and some things are getting hung up around the classroom. That's why we're facing this weird angle. I didn't fully explain that earlier. I got sidetracked. But we're facing this weird angle because I didn't want to spoil what it looks like over there. Apart from the one thing I could not help but spoil, which is this clock. I got this for pretty cheap, actually. The hands, I think, are frozen. They're like rusted in place. So I get, what time is it permanently stuck to? Let's see. It's stuck to, oh, it's not a real time. This one is, the amount it is through the hour is not where it would be over here. So it's trying to be 10:10, but it's a little askew. Oh, no, wait. Would this mean halfway above? It's like at the center of the number, but the numbers have little zones, too. Okay, anyway, it's frozen. It's a stopped clock. Now, no matter what time it's stuck on, it's right twice a day. Even if it's in an impossible position, somehow it's right twice a day somewhere in some dimension. So there's also, Wade mentions the Euler line connecting 3 certain centers of the triangle. Yeah, those are cool other facts about triangles. Will be like, these are 3 ways of defining the center of the triangle, and they're always in a line, or stuff like that. And we have a note that even Napoleon found one of these circle centers that's named after him. That's neat. Oh, Evan Escher said they can't see the clock. Sorry. It's hard to see exactly what's going on in my camera when I'm looking at the chat. But this is a large clock. It's the largest circular clock, tied for the grandfather clock for largest in different ways. And so you'll see a better view of it in the official grade -3 intro in about a week. And that'll be when everything's all hung up. But this one I got to be careful with. That thing's heavy. I don't want that thing falling on me, but we'll see. And There are other notes in our comments from people like Inspirator about some other cool ways that circles and triangles connect. And it's always nice to see those connections between different polygons. Now, related to triangles of numbers, you know how I've been talking about triangular numbers? Well, a lot of people don't think about the fact that square numbers are in a family with triangular numbers. Triangular numbers are number 3 of that family, and square numbers are number 4 of that family. You can have pentagonal numbers, a little lower than triangle, you get more boring. You get linear numbers, you get a dot. But that family has some crazy properties. And one of my favorite things that I read, that I just read that it was a fact, and then I put together in my head later, like the implications of it, is that in some ways of looking at it, this sequence is what's really natural. This sequence of triangular numbers, square, pentagonal, etc. Triangular numbers have a slightly weirder formula in terms of it's n times n plus 1 divided by 2. And that exactly makes us think of triangular numbers more as a geometrical thing and not think of the equation for them sort of secondarily. Square numbers, almost in a weird way of looking at it, get lucky with this there's a generalized formula for all of the different types of, that type of figurate number are the polygonal numbers. And there's a generalized polygonal number formula that if you plug in 4 for a certain point, it reduces to just n squared, which is what we associate with square numbers, that you square the number, you multiply it by itself. But really, the fact that squaring something means multiplying by itself can be seen by this one generalized formula kind of getting lucky when a different variable in it is set to 4. And so that's another triangle-related thing we will look at in this grade, how triangular numbers are the seed of this whole family of important numbers that includes square numbers after triangular numbers in the sequence. The square numbers aren't necessarily much simpler in every way than triangular. They just get like a luckier formula in some ways. And they do line up in other types of geometry neatly, but triangles have their own forms of neatness. And with those, we'll probably have that episode in this grade, and then separately another episode where we go up dimensions, because you can also go from triangular numbers to stacking things in ways. For example, if I stack square numbers, but stack smaller square numbers on top of them, like 25 with 16 on it, with 9 on it, etc., those form square pyramids, and square pyramidal numbers are a type of number. And you can have numbers that are tetrahedral numbers, are if we're stacking triangular numbers on each other. And if we're stacking the same square number on itself, we'd get a cube number. And so the connection between things like squares and cubes with triangular numbers is pretty awesome, and triangular numbers love 3. It's not just that they're triangular shaped or the third one or whatever. They love 3. A lot of triangular numbers are divisible by 3. Triangular numbers, 3 is the first non-trivial triangular number. And triangular numbers and 3, they are, well, triangular numbers made 3. It's not even a friend of it. They're like its creation. So those will make for some fun topics. And not everyone, as the chat notes, have even thought about the fact there would be tetrahedral numbers. And I love things like that are connections you can even make in your own head just by pondering concepts where you're like, we can change one of the words in the thing that I knew was a phrase. And does that exist? Because in this context, this could be changed to this, like a triangle could be a tetrahedron. So could a triangle number be a tetrahedral number? Thinking of those connections and extensions is great. And Bjorn Larson also notes that I like super 11s, although I do often call them hyper 11s, but I know what you mean. And there's a note that Rosen-Pascal's triangle consists of powers of hyper 11, which are basically powers of 11. And this relates to them being basically binomial coefficients, which we'll go into in an episode like that. But yes, Pascal's triangle is all about Hyper 11s. And tomorrow's Hyper 11 day. Maybe it's already for some of you. November 11th. 11/11. So make sure tomorrow to try and catch one of the two 11/11s, or if you live in somewhere with 24-hour time, you only get one chance. Try and catch an 11/11 tomorrow. And when you do, look at that clock and say, man, ones are pretty cool. Look at everything right here is just ones. My time, my date. Ones can do a lot when you stack them in a line. And praise the having -3 ones in a row in preparation for our grade. Sometimes the analogies break down when I try and bring it to -3 instead of 3, but we can take it in a metaphorical level. And similar to wondering if triangular numbers could be tetrahedral numbers, you could wonder for any concept named after a number, what about the negative version of it? Like when one day I stumbled across something about a negative base, I was like, you can have a negative base? Like I had been researching other bases, like, okay, you can have base 2, base 5. You can have a negative base? And then that made me wonder, can you have an imaginary base? So I started looking that up. And those have been episodes I've made on the Combo Class channel already, but adding a negative in sometimes does cool stuff. What about so-and-so, but negative? And Real Tal or Tal likes the squirrels. They're the favorite part of the insanity. There's a long section about the squirrels in the finale episode I released recently, linked in these comments. A whole thing, like a sector all about the squirrels. And there will be more squirrels in this next grade, but I may be feeding them a little less. They may be running by already having nuts a lot more, because one of my neighbors is giving them a lot of nuts these days. So I'm cutting back on giving them some nuts because I want them to still know how to forage and teach their kids that. So they'll probably already be carrying nuts when they run through the background now. But trust me, the squirrels are still visiting this yard. It's one of the neighbors that shares part of the yard over there with me. And so there will be squirrels maybe already bearing nuts. But I do have a new bag of walnuts just slowly dispersed to them because although you should not feed wild animals, these squirrels have gotten pretty domesticated and they still do forage for stuff in between eating random fruit trees and stuff. So a walnut here and there is healthy for them as long as they don't get too dependent or whatever. Because, but that doesn't mean feed a wild animal in a park or something. The walnuts are actually good for their teeth as well. It's good to open the shells for them. And Wade Eberly wonders, does every platonic solid have a series of numbers like that? Meaning, like, could you have octahedral numbers or things like that? Now, you can make essentially any shape into a type of number. Sometimes there would be a few ways to define it in that, like, if I say, I'm going to make house numbers, they look like a house. They're a cube with a square pyramid on top for the roof. There's maybe a few ways I could define that. Like, is there a point where the base of the square pyramid equals the next one being the top of the cube, or is that one considered the top of the cube? So there could be a few variations, but coming up with any shape, there will be one or more ways to visualize dots forming it. So a surprising amount of shapes do have what we could call figurate numbers, or in many of these cases we could call polytope numbers. Like you could have polyhedral numbers or polygonal numbers. You could have the general category being polytope numbers, and the even more general category being known as figurate numbers. Numbers that are a sequence you could generate based on a visual thing such as an amount of dots representing some shape. And so that is a pretty cool merger between geometric things and algebraic things. And we will be diving into that. In this grade, there's also a lot of ways where 3 is just like the star of the show. If we talk about like magic squares, 3x3s are the minimum. We're going to talk about something called the intransitive dice. 3 is the minimum. Maybe we'll talk about the base radix of things, and that is can be closest to 3 wins an award there because it's close to E, is why it wins a certain award there. But all sorts of 3s will show up, and I am actually incorporating a lot of stuff related to 3 even numbers into another project of mine, which is a fiction book I've been working on for a while. There are several books I've spent a long amount of time on, but haven't polished up yet, that I hope to get into publishing at some point. And although they are fictional, I believe my viewers will find them interesting. They do have mathematical combo class-ish things throughout them. And this first one does have a lot of things related to 3 even numbers. So I don't know if I'll be able to get that out this grade, but out of all the side projects that I like to work on, one or another, I'll make sure to try and start releasing this grade. Maybe some card games, maybe some more music, maybe some of my written work, and of course the videos that I love to make. And we have a comment about ternary. Base 3 is pretty cool, and you know what else is pretty cool? Balanced base ternary. I've made an episode about that before too, so if you haven't seen that, any of you, later on watch my episode about balanced base 3 or balanced ternary, where the digits you use are -1, 0, and 1. You don't write it as -1, you have a symbol for it, it's its own digit, and it makes a really cool symmetrical pattern. We also got a comment about the train, and yes, those are train noises. In fact, if any spy wanted to hunt me down, they could probably figure it out based on distance from trains and such, but they're not going to come here. They would be in for bad surprises, all the intruders. They'll trip on the body of the last intruder. I'm kidding, probably, but anyway, yeah, so we do live by the train. I'm not that many blocks from a train over there. And I do pass the train tracks a lot because that leads to the marina areas that I've been going more and more since I only recovered from some surgeries I had to get. Like a year ago, I recovered. And so I've been starting to take a lot of walks out in nature again, particularly at the marina. Although today I did go with a friend up to a park up in the hills, a foresty area. This one was Tilden Regional Park, for anyone who happens to know the parks of the Bay Area or such. And if anyone wants me to visit anywhere weird and cool, what you could do, look at the maps of the East Bay Regional Park District. Those are a lot of my favorite parks in this region, and some parks that I haven't ever been to yet. And some of them I have been to literally more than 100 times. Some of them I have never checked out yet throughout my life. And so leave a recommendation if you're bored of a cool seeming location in the East Bay Regional Parks, and maybe I'll visit there. But I've also recently just been taking walks down by the marina to catch sunsets and weird birds and stuff like that. And I need to get a better microphone to bring down there so I can record down there easier, because it's always so windy down there. So sometimes I've just been getting like B-roll, like here's a miniature shot I'll throw in somewhere. But I want to actually be able to record more shots down by the marina, and it's really windy. So I need like a closer microphone to me. I will be upgrading before long. And Wade's wondering if I've heard of a slide calculator, an addiator. And it's sort of like a discrete slide rule, they say, for simple additions and subtractions. You slide different sliders around for each place value. I think I know what you're talking about. I'm not 100% sure, but I think I know what you're referring to. And I do want to get more devices like that around the classroom because, got to admit, I like analog-ish things. I'm not a big hyper digital guy. I mean, digital I am because I love digits. Digits are great. I'm all about patterns with digits. But in terms of the digital technologies that have emerged, I don't use that many of them. I use my laptop. I use my camera devices. I sometimes use music recording devices. That's most of it. I don't use that much technology. And so, like here, this is the extent of the technology I'm using right now, apart from what it takes to live stream. And so I don't even know where my phone is right now, for example. And so I like old stuff. I should get more of those old school mathematical devices. We already, in the classroom, I have some abaci, but I should get more Abakai-like things or slide rule-like things. And we have a recommendation about some East Bay regional parks from COF CPR, which is that Huckleberry and Sibley are both nice. I have been to those places many times. Sibley has the cool labyrinths, which Sibley is a bit drier. It's not quite as lush of nature as some of the other parks. Some of the ones near it I would more commonly go to because they have rivers or redwood trees or stuff like that, more so than Sibley. But with that said, Sibley has these cool labyrinths that were made. Actually, oh shoot, I want to show you folks. I saw a labyrinth today when I was in Tilden. I was talking to my friend about how Sibley has these big labyrinths people make. And not long after I was chatting about that in Tilden, we came across a smaller brick labyrinth. It was a sort of weird shape, but I'll call it a labyrinth. Shoot, okay, if I need to run inside in a second, which I might need to do for a very brief intermission, I will grab my phone that I recorded a clip on to show you a labyrinth that I saw today. But that's why I would go back to Sibley, to go to some of the labyrinths. I even know some labyrinths that are off trail that not that many people probably know about. In these parks that I've been to, I grew up around many of them, and so I know a lot of rare nooks and crannies. And we also have some notes about dimensions. Jordan Blevins says, among all possible dimensions, only in 3D can you have one dimensionless, can have one distortionless spherical wave propagation with attenuation. Interesting. 3 dimensions has some neat traits. For example, 3 dimensions is the only one that works for taking this thing called a cross product. If you want it to be fully unique, you can do it in 7 dimensions in this like more flippable way, kind of complicated. But 3D does have some traits that only exist for 3D. And as far as we know so far, 3D is pretty important to whatever is going on in the universe because we're sort of like able to manipulate 3D things and seem to be sort of flipping through 3D slices as time goes on. So 3D has something interesting to do with the universe. We're not sure. Some string theory guesses say maybe there's more than 3 dimensions. Maybe some dimensions are tinier than others or wrapped around each other in weird ways. Maybe there's 10 dimensions. But 3 dimensions definitely has something going on with the fact that our perception makes it seem very like we live among 3D things we are able to manipulate. And so 3D, we will go into the 3rd dimension being part of this during the grade, but we'll save some dimension topics for grade -4 because that will be extra fitting to go kind of beyond what you normally know about dimensions when we go into the 4th dimension. There is a lot I want to say about the 4th dimension, about ways we can try and conceptualize it via shadows or cross sections or things like that. And so the 4th dimension and other dimensions will come up. And some dimensions do have just weird properties that only that dimension has, including some that only the 3rd dimension has. Evan Escher is wondering, do I wear a mic in my combo class vids? I have before, I will admit. Since I'm kind of low tech, currently I've just been using the mic that is on the camera. So that's why I talk a little louder if I have to be further from the camera for the shot I want. And then I also edit it, so I sound mix it later. So I turn some stuff up, turn some stuff down when I'm putting soundtracks on and stuff like that. So I haven't currently been wearing a mic. It doesn't help. I'm not recommending not to because it makes it harder to sound mix and it makes it harder to film at places like the marina. So I do want to start wearing a mic more often, but a lot of the time now I don't. And I'm like, okay, there was too much of a weird construction noise in that shot. I got to say the line again. Or I have to be like, okay, I'm pretty far from the camera for this shot I want. This one's going to have to get turned up a lot in editing. Now, on my bonus videos on this channel, sometimes I upload them straight from the video file. I trim the video file using QuickTime Player, but I don't, sometimes on the single take videos on this channel, I don't even put them into a video editing software. I just trim them and upload them. So those one take ones don't have any audio mixing or anything. I know they're probably a little quiet because a lot of you, there's a loudness war. All the things need to be louder to be heard more than their competitors. And things just get louder over time. And so I'm not as loud as some channels or perhaps some advertisements. Maybe I'll turn the volume up a little more if I start wearing a mic, but you could always just set a level that works for you. I try and audio mix them so they're digestible, but also, given that takes a lot of time, I try not to be too perfectionist about it either. Now, Inspirator notes one of the most powerful properties of the circle is omnidirectional symmetry, which you can use to solve a circle's tangent. And Thales theorem, I don't know how to pronounce the name. Is it Thales? I'll go Thales theorem, or the fact that chords are perpendicular to diameters. And yeah, another way in which circles tangent to things such as triangles and other shapes cause a lot of beautiful theorems to come up. So we will go into more theorems related to circles and triangles. In fact, one of the scrapped combo class episodes, there have been a few episodes I filmed like half of the episode and then didn't end up finishing it. And I was like, I'll do this later and put what we filmed as a flashback or something. For whatever reason, it didn't make sense at the time. One of those was about spheres. So I have a few minutes of footage of me ranting and crazy stuff happening about spheres that maybe will be a flashback someday when we return to the topic of hyperspheres. And Stevie Trudell says, will I be making videos documenting my exercise workout routines this grade? Because they're also trying to get back in shape and it could be inspiring. So I like that idea. I like sharing a lot about my life. I also, sometimes when I do too many things that aren't pure math or science, if I do too many other things in a row, it bores some of my viewers. Now, this is my bonus channel, technically. Despite having more subscribers than the combo class one, this is my channel to do whatever I want on. So I still try and ignore that and just do whatever I think's fun to put out. Sometimes it's a lot of math in a row. Sometimes it's random stuff in a row. So I like the idea of doing that, but I'm going to have to somewhat balance that with the idea that not all viewers will care about that. But I do like the idea of some sort of, at least one time giving recommendations for good exercises, and at least one time showing updates throughout my progress. I also wish I could take live streams out on hikes. So I might film a bonus video or two where I'm just talking while on a hike, while somewhere beautiful. So, because that's a type of exercise I get a lot, just wandering around cool nature areas. Now, for like muscular exercises, the thing is, I still have some physical conditions related to the surgeries I got a few years ago. Someday I may need to get shoulder surgeries. I have a similar bone issue in my shoulders that I had in my hips that required hip surgeries. So I have sort of unique exercises given to me by a physical therapist that are less muscle intensive for a short time and like sort of slower and longer amount of time, because I'm not supposed to lift super heavy things, or it's sort of speeding up the process of how soon I might need a surgery on those. And so it's really annoying. It's not fun. It's sometimes hard to be me. Like, I'm not supposed to lift heavy things. Great. But and I mean, I can still have the muscles to lift heavy things. It's just like not good on the long term, whether or not I'll need a surgery on them someday. So that's all really annoying. The good news is the surgery is on my hips. Perfect. I feel like, oh man, I can walk again. Thank God to those surgeons. So if I ever need surgery on those, I'll get through it. In any case, what I mean by that is that my exercises currently are a little less applicable to everyone because I saw a physical therapist, and so it's sort of tailored to me. However, I do know a bit about exercise. I actually used to be in really good shape. I had a six-pack. I had pretty good muscles and stuff. I mean, I wasn't like a full gym guy, like super bulked out, but I had like a six-pack and stuff when I was, say, about 20 years old or so. For reference, I started making combo class when I was 28 or 29. And so by that time, I was in all right shape, but this past year, I honestly gained a lot more weight than I have in the past, and I'm probably more weight than I've ever been, or maybe I was a few weeks ago. Might have been my maximum ever. So I should really take one of those before photos in case it comes in handy, where I like have my gut out and I'm looking to the camera like this is before I exercised, so then I can compare it with when I do get really muscular. But to some degree, I will throw in things about exercise because not only, maybe it'll be inspiring to see, despite my weird physical stuff and it being harder for me to exercise than the average person, I do intend on getting back into really good shape. And apart from the inspiration, just because I like teaching about random stuff, maybe learning a few random exercises you can do will be helpful for people. There will be occasionally throughout my different grades different random things I do in life that I'll share my tips about, cooking or this or exercising or that. And so maybe I'll mix some of those in. Thanks for the note that at least one person would be interested in how the exercises are going. So I'll keep that in mind. And Wade also mentions a channel that he recommends of Chris Staker, who's recommended about talking about old calculation devices, like old versions of slide rules and stuff, I'm guessing. Sounds kind of interesting. Maybe I'll check that out sometime. And I guess I kind of keep getting distracted to circle back to the question of if I use mics or not. In the live streams, I don't, and it's going through the computer right now, and it's as loud as I can put it. I've gotten comments before that it's not that loud, that it's pretty quiet overall, so sorry if you got to crank my live streams louder than average. And while you're watching the live streams, there won't be, at least currently, any ads that will pop in your face if you're watching this live, because I don't put ads in the middle if you're watching it live, so luckily it won't be that jarring. I guess if you watch it after the fact, there could be a really loud mid-roll ad that comes on once it's like in video form. So hopefully the sound difference isn't too off. Maybe I will get I have a few mics to test more that I'm genuinely just don't know that much about technology and don't enjoy the testing of them and stuff, but I will dedicate some time to test the mics I already have or other future options, because at some point I will have a microphone here while I'm live streaming. That will sound better. Audio upgrades are the type of thing I want to do over my grades, have the audio sound better and better. Partially how clear it is, and partially the soundtracks I put in some videos, which I create. Maybe I'll make even better new ones. And with the audio, that will improve, but don't worry, Chaos lovers. We will try and get the things more polished in the Combo Classroom, video and audio-wise, that help it come across as smooth as possible, but it still has a little chaotic edge. So we're in combo class. Some things might be a little loud. Sorry about when they are. Maybe someday we'll have the quiet whisper stream only, and I'll make sure that the entire stream's whispers. For now, even I cannot predict what the next minute will hold. Maybe a squirrel will jump down and lick me and I'll start screaming. I don't know. So audio, I will keep a eye on as I move forward. I do work with different camera people, and as time goes on, I will get better at collaborating with more people with other skills in the operation. People who are good at editing or recording audio or things like that. For now, it's basically me and some camera people who I hire to help me from time to time. But I do hope to expand the combo team, and I was quite introverted throughout grade -2, but now I've just recently begun going through all the emails I've gotten in that time, all the messages and things like that, and am intending on replying to all of you folks as I begin this new grade, or hopefully before the official intro for most of you. And in grade -3, I will be more involved in the combo community and places like the Discord, which is also linked in the description here, as well as trying to collaborate with people to help me with those things. So I don't have to think about what would make the audio better stuff. I'm at my best when I am more of a creative force than a technical force, when I'm the one thinking about scripts or set design or presentation, as opposed to the one thinking about making sure the tech comes across, although that's a very important job as well. And Wade's cat Possum, who's chilling, with them says hi. That's very nice. It's dark enough out here that I can't tell if any cats have crept by. They're really quiet sometimes, and my cats like creeping by and visiting. So, for all I know, one of them could be here. They blend in, they only have tiny bits of white that are usually not showing in the dark. But I haven't seen any of the cats right now, but all three of my cats are doing lovely as well. They are so awesome. And so, thank you all for commenting and stuff. Now, I do want to get to some more fun graphs and stuff. I want to run inside and grab some water. Sometimes talking for an hour does make my mouth a little dry. And when I run inside, I also want to get my phone because when Sibley came up, it made me think of labyrinths. And I want to show you folks the labyrinth I randomly stumbled across today. So I'm going to run inside for like 2 minutes. While I'm in there, I might as well make a cool thing to go in the background. So let's make some cool shapes and we'll involve -3s in them. Let's have this shape relate to and trigonometry. Have you ever thought about how trigonometry relates to 3? Trigonometry, triangles. So the word root, it's kind of complicated for trigonometry, but let me actually look it up instead of trying to describe it. It's a combo of 2 Greek words that's now a Latin word, something along those lines. Trigonometry is word root. This comes from the Greek words trigonon, which means triangle, because it's like a polygon, trigon, polygon, triangle. And metron, which means to measure. So, triangles, because trigonometry is all about triangles and circles. So, in fact, when we were talking about, triangles and circles are such good friends, another proof of that is just, well, trigonometry is a pretty big subject, huh? Because that's all about triangles and circles. So, I'll keep this actually open like this so that we can just put like some random graph to do a little animation while I run inside for a second. What's that going to look like? Yeah, that didn't do the trick yet. The -3s might be throwing it for a loop. Okay, we'll do second powers for now to make it a little easier to make something wacky happen. We'll do some -3rd powers. We'll stick a -3rd power here and there. Let's see. Okay, now let's stick a variable somewhere. And then we can move our slider and things will change. And now let's make a clone or 2 of it that are different colors. This is just how I make, we're using numbers on the graphing calculator, a random free online one I like called Desmos. We are now putting things in random places and we are going to make cool equations that will make a whole background screensaver while I go inside. So who needs someone else's screensaver? We're making our own one, and this is it, except this should slide way slower. So this is our really random sloppy animation. It's pretty chaotic, but it will evolve for a second, and I will be back quite shortly. Okay, I have returned. It's so dark, I'm tripping over everything. And first, like I mentioned, I might as well, since I brought it up, show you the labyrinth I encountered today. I also might as well pause that in case it makes things slower. Thank you to everyone who's stuck around for our I called it a prequel, but as someone pointed out, prequels do not typically come before the actual thing. So we'll consider it also a bit of a preface. And here are some examples of some cool places that I did see when I was hiking today. This one I was like, oh, I wish I was doing a full filming day because I would have been in this little cavern. Or check out this other place that you could go inside. I would have gone in here more. So I'm going to maybe go back there to film in this weird hut someone made sometime. It's just like, I don't think someone lives there. I think they just made it for fun. And then the labyrinth I was mentioning is, I came across this labyrinth thingy. It was made of bricks, and it was hard for me to like get an upward shot to see it all. I did get a shot of me walking through it, but that's going to be sort of bumping around a bit. But walking through the labyrinth, you just have one path you walk through until you end up hitting the center. And when you hit the center, you get to the Minotaur, as the old myth says. Labyrinths have an interesting mythical origin. They're a maze-like structure, but not really like a maze that has twists and turns, more of like a circular maze. And they have a sort of strange meditative vibe. This one was a sort of weird shape, where it wasn't quite at the center. But one last view of it is, if you were coming from the side, you would be seeing all these nice berries. And then you'd go past the berries and, wait, what's going on? I'm bumping it. You'd go past the berries and you'd stumble through the trees. And you know what you'd stumble into? A labyrinth. So there's a lot of cool places out in nature, especially those things that were mildly interacted with by a human or other animal, such as someone who built a little labyrinthian structure. It kind of reminds me of the other day I was walking at the marina and I saw sometimes people down there build these rocks stacked on each other that must take a long time to put together. This is sort of a miniature version of that I'm going to show right here, because it's not like the tallest one I've seen. But look, somebody stacked all these rocks on top of each other. They have to balance perfectly to be there. I came across that and I was like, neat. And sometimes I've seen even taller ones. So nature with just the smallest amount of human meddling can be pretty awesome. I like things when they're like 20% human, 80% nature. You also can get there when you have a human thing that has collapsed and nature has returned and retaken its 80%. Nature transforming, breaking down cycles. And we are at the beginning of our new cycle of the grade. And I want to talk about it, but I'm going to bite my tongue from talking about it. I will say, I live in the US and there's all these other big shifts occurring right now. I kind of put my beginning of the grade, I realized, at a weird cultural time where there's other big shifts occurring in America. Not going to get all political, but I'll say I'm not super excited about the way the election went. So that's what I'll leave it at. Anyway, back to triangles and threes. 3, as well as, of course, -3, will get lots of fun traits analyzed. And if you look at the Wikipedia article for 3, wait, first let me check. There's this site I love called Numbers Aplenty. And they have all these traits plugged in, where they plugged in what all the triangular numbers are, plugged in what all the Fibonacci are and such. So then you can search a number and it tells you which of those it lines up with. And sort of like you could do on the OEIS, Online Encyclopedia of Integer Sequences, but one that collected them pretty cool is called Numbers Aplenty, and it wasn't loading earlier. I hope they didn't take down the website because they couldn't afford the hosting or something, or have an issue with it or something. That one's not loading. I can't look up 3 on there. Luckily, I already know a lot of the traits about 3, because 3, it's a small enough number to study a lot, especially if you're a big fan of it. We do have to watch out for some overly spiritual things related to 3. It does show up all over nature and makes sense to show up in philosophy and spirituality, but 3 is not the end or answer to everything. 4 is going to do some stuff too, and 5 and 6 and 7. So don't get too lost in the trap of 3's importance. If anything, we are worshiping the point of 1, 2, and 3 now having combined up to 6. But anyway, looking at 3, you can see there's a pretty long Wikipedia article all about different aspects of 3. And just to skim through a few that they list, some of my favorite ones, like I said, will show up in the official intro episode. Some of the other side ones I showed earlier in this stream. But if you want to see some of your own facts in the meantime, Wikipedia is pretty decent for math. They're less trustworthy on historical things and on certain things. They can, there's going to be bias when people are contributing to anything, any source. It's not just a flaw of Wikipedia, it's a flaw of how we must digest knowledge with other humans who have biases. But with math, there's less of a bias from anyone, and so the math on Wikipedia is pretty good. I haven't noticed that many times where it's dreadfully wrong. If anything, there's a lot of times where it's like, oh, they should have mentioned this other thing. If I was already plugged in as an editor, I would add this thing. But then I would have to find the right source for it, and etc. But they're not usually dreadfully wrong. So you can look through them, look at the facts, and be like, whoa, that's neat. And then if you really want to quote the fact or use the fact in something, then you're going to want to look it up on another site too. There's been once or twice I read a cool fact on Wikipedia, and I could not verify it elsewhere, so I didn't put it in a video. And so there's 1 or 2 facts that I still have in my notes. Like, is this true? But usually Wikipedia is pretty good at things like just stating a bunch of different facts about a number that are mathematical and can be verified as correct or not. And in base 10, for example, they note 3's cool traits. These stem from the fact that 3 is, it turns out to be the square root of, but just that it's a factor of the number 1 less than 10, the largest 1-digit number in the base. If you're a factor of the largest 1-digit number in a base, you get cool additive divisibility properties. Kind of like if you're a factor of the base itself, you get really simple divisibility properties. You end in a certain digit or not, if like multiples of 5, or if they end in a 0 or 5 or not in our base, because 5 is a factor of 10. The addition properties come from, like, you can add up the digits of a number, and if it's 3even, the digit sum will be 3even, if and only if. That comes from 3 being a factor of 1 less than the base. Now, this all points to the best base being base 6, because in base 6, 2's and 3's are really easy to work with instead of 2's and 5's, but 5's are about as easy to work with as currently 3's or 9's are, because they're the one less than the base. 7's would be as easy to work with as what 11's currently are like. They have a lot of patterns that are simple. And so all of the small numbers would be covered in good ways. 4 is, not exactly a factor of 6, but it has factors in common. They share a factor of 2. And so all the small numbers are either related to factors of 6 or are neighbors to 6, 5 and 7. So, in fact, if we look at numbers that either share factors with 6 or are neighbors with it, covers the first 10 numbers. That's what our base is trying to cover. So if base 6 covers the first 10 numbers even better, what are we doing here? So we'll probably get deeper into that at some point. I've made a number of episodes about bases, and I would be interested, actually, for any of you who haven't yet heard any reasons exactly, apart from what I just said, about why base 6 would be good. Can you put it together based on other facts I've said about numbers and things I've said about bases? Can you figure out some reasons, there are several, why base 6 would be good? And there will be an episode I'll make at some point that is a much more clear, singular, this episode is about why base 6 is the best. Because someday, I actually believe there's a decent chance someday there will be an apocalypse that kills almost but not all the humans, and when society rebuilds, it will switch bases, and I'm hoping they go for base 6, and if they end up going on base 6, then it's going to look like each main channel combo class grade Each season of my show has 100 episodes. I made exactly 36 main episodes in grade -1 and grade -2 because I foresaw how important 6 would be. And it's coming truer than ever. I'm so glad that I had 6 be the core of it, because the more I learn about numbers, the more underrated I think 6 is. Now, Bjorn Larson asks, what base did ancient Greeks use, like Pythagoras? They used letters as figures, right? Well, things evolved for a lot of times. Now, the numerals we use, like the specific number symbols, are Arabic or Hindu Arabic characters. And so those were introduced at a later date, I believe. I need to read more about the history. It is, when you ask that, it makes me think, I want to read more about that. But from what I know, at the very early points were when they were describing numbers more as lengths or distances. For example, 3 would be seen more as a ratio of line segments where one is 3 times as long as the other, or a ratio of angles where that's the case, or things like that. And so at some point they did shift to other sorts of bases, and I'm actually not sure what base the Pythagoreans used. My gut's telling me 10, because that's been pretty common due to the 10 fingers, even though, come on guys, there's 3 notches on each finger except the thumb. The thumb only has 2 notches. The thumb is an opposable thumb. It's different. That makes humans able to grab tools. The opposable thumb is basically why humans are the dominant species. And so what if the thumb is the counting device instead of one of the count-ons? And so look, 1, 2, 3, 4, 5, 6. I got 4 sets of those right here. It makes sense to use 3s somewhere. 1, 2, 3. 1, 2, 3. It's 3s are everywhere. The insects, 2 times 3 amount of legs for one insect. 1 times 2 times 3. So, anyway, what base the Pythagoreans used, I'm not positive. So let's look that up. What base did the ancient Pythagoreans use? Now remember, if I look up something quick on a live stream, it's to get us a guess of the answer. If we really want the answer, we're going to read deeper. Like later at some point, I will look at multiple sources and look deeper and see what's really going on. Don't take my quick Google searches as, okay, we've learned it, we got all the research done. These are sort of just out of curiosity, checking the tip of the iceberg of what one source says. I don't want the AI overview. I'm not counting that as even one source. Here, the ancient Greek counting system was based not on 60, but on 5, 10, and 100. So sometimes it wasn't always as strict of a base as we think of numbers, where we think of them as every place is the same amount multiplicatively scaled up. If we're in base 10, each place is 10 times worth the last. It wasn't always that simple and direct of what we'd call a positional numeral system, and in fact, those would be called a standard positional numeral system. And I call them the basic bases. That's my nickname for base 2, base 3, base 4, etc. The positive integer bases of 2 and above, I call those the basic bases. But technically, we would call them there's a few names, but we'd call them something like a standard positional numeral system. And here, it looks like they had symbols for 5s, 10s, and 100s. So it was kind of like that, but they also had symbols for 5s. As you know, like Roman numerals don't scale up exactly like that. Money denominations don't scale up perfectly like that in most places. So a lot of times the symbols aren't as easy as they're a geometric progression of how much they're worth. So at some point they got a little more into that, but it looks like they used 5s in that mix as well. And 60 was also a common one introduced in Greece, according to this quick source, which makes sense because I know 60 has been used throughout much of history as well, having symbols related to 5s, like a hand, but also related to a dozen, which shows up here on the hand, the amount of segments there I could count, and dozens show up all over. 12 is 6's big cousin. Half the stuff that makes 6 cool, 12 also has. 12's, I like 6 more. 6 has some stuff 12 doesn't have, but 12's totally 6's cousin, has a lot of the same cool traits in common, both super divisible numbers. And so 12 just makes sense. If you're dividing things as a society, which one of the first uses of numbers was to keep track of, like, okay, I sold you half my corn or something like that. If you're selling half the corn, you don't want 11 stalks. If you're selling a third of the corn, you don't want 10 stalks. Well, what about 12 stalks? Then we can sell a half, a third, a fourth, a sixth. Now, 12 makes sense. So 5s and 12s together made a lot of bases function kind of like a weird version of writing base 60. Now, or kind of like a base 12 that resets after 5s, or a base 5 that resets after 12s, or stuff like that. And there's other notes about counting fingers in funny ways, and I do want to make an episode someday just about finger counting. Sounds like a limited topic, but you can count on your fingers in many ways. And there's this classic way where you can use your fingers to represent binary digits, like up is a 1, down is a 0. And so here, using 10 fingers, I could go pretty far. I could represent up to almost 2 to the 10th power, because it would be full of ones would be 2 to the 9th power plus 2 to the 8th down to 2 to the 0th. So right under, this would be a hyper 11, right under 2 to the 10th power. I could go up to 1023 using that binary system. But could we go further? You know, like there's more things we could do than just that. And so I was thinking of how could you have a system of counting on your fingers to represent a number that you could go way further than 1023. And also just looking at other logic behind fingers. That may end up being a whole episode someday. And we also have a note from Wade saying it could be cool to do a video about the different religious or spiritual or superstitious significances of different numbers. For example, 3, 4, 10, 13, etc. That would be fun. And they come up randomly in our live streams with things like noting 13 often being considered unlucky. So I try and flip that around and see it as a lucky thing. In some cultures, 4 is unlucky, and other cultures have different things. And in fact, 13 being unlucky, I believe there's many different origins related to it. A lot of people say knows this. There's several origins as to why 13 has gone down in history as being unlucky. And one of them, I believe, that's a somewhat more like big scale thing about all of them, is that it being almost a really divisible number, a little off a really divisible number, feels somehow weird. And so other numbers sound like something in a language, or the symbol for them looks like something in a language, so the number's unlucky. But cultures take it pretty far. Some places skip numbers on the floors and just lie to you about what floor you're on. No, trust me, you're on the 14th floor. 13th floor, that don't exist. So maybe that would be a fun type of video. I'm not sure, either a full episode or maybe just bonus video looking at unlucky numbers, for example. But there's also spiritual significance of numbers, and 3s are worshipped in many cultures. And like I said earlier, try not to go down the rabbit hole of thinking at any point in this grade, oh my God, 3 really explains it all. The universe is all 3, because we'll approach that to a degree, but the other numbers are doing cool stuff in the universe as well. And for example, Tesla, not the car, the old Nikolai Tesla, he really thought 3, 6, and 9 were magical. Somewhat based on being in base 10, a little skewed view of it from him, and some people are like, 3, 6, and 9 explain the universe. Now here's the thing. The reason that bugs me is because it's almost true. Things that are like not true are easier to just be like, that's wrong. Things that are true. But things that are like almost true, sort of, you're like, oh, come on. No, you're like making it look like it's that, but it's actually that. Because the thing is, 3 even numbers are awesome, but there's no reason it should stop at 9. 3, 6, 9, 12, 15, 18. Let's keep going. Keep them coming. So 3, 6, 9, and then cycling back to 3 is patterns that occur when you multiply modularly, or you look at digit addition or things like that. And modularly, you can get to, in base 10, 3, 6, and 9 forming this magical triangle. But in a different base, they would do something else. And so that's something that people get like weirdly spiritual about. 3, 6, and 9. It must explain it all because this great inventor thought that it did. Well, I'm sorry, the great inventor knew a little more about science than about math, was also a kind of wacky guy, and was just a little obsessed with 3, 6, and 9. I say let's bring 12 in the mix and share some credit with the other three even numbers. But 3, 6, and 9 will do cool things we can observe in base 10. They are awesome, they have a cool partnership, but they're not the only three even numbers. And we have some questions about aliens whose brains can handle more symbols than us. Like if they could use base 5040, super divisible number. 5040, highly composite, like 6 and 12. But if you could store that many symbols, it would be easier. And yes, I do think actually that there could be aliens that it would make sense for them to use a much larger base number. And that when designing base numbers, some of the best ones are things like the ones called superior highly composite numbers, which will get an episode soon because I've made an episode about highly composite numbers. These ones got a little special star next to them in that episode, but I didn't dive into their definition. But they have like a main definition that's weirdly kind of hard to digest mathematically, but I'll try and explain digestibly. Then they have a connection to this cool pattern that the mathematician Ramanujan found. Great Indian mathematician who discovered really cool stuff. And they connect to this really cool sequence of prime numbers. So the superior highly composite numbers will get an episode, and I was searching them up to just look at. These are, under many standards, the best numbers to pick as bases. So, depending how big your brain is and how many symbols you'd want to store, these are good options for what number you might, the blue ones here, for what you might want your base to be. 5040, as we see, is on there. And look, I like this one. 720, 720. Look, it's a clone. This one's like a clone of that with an extra 5. You get some interesting patterns because when you're multiplying in low primes, the 7 times 11 times 13 multiplies, try it on a calculator, you'll see, multiplying various stuff by this does funny things. I made a short about that once. But later I will show more about superior highly composite numbers, but I wanted to show, if you had a slightly bigger brain as an alien, you might want base 60 or base 120. There's also the practicality of if you were drawing 2D shapes, how many, like, you'd need more complicated symbols because there's only so many distinct 2D shapes of a given amount of lines or size. And so when you hit base 60, you could be limited by that as well if your symbols are being drawn in a glyph-like way like ours. So that is another limitation, is can they write really quick, and do they have really good pens and eyes to see that? So there are other factors than just how easy it is to digest the symbols, but based on those factors, I could imagine aliens running on one of these other bases. And although 10's closer to 12, so some people think, oh, come on, let's add 2 digits instead of subtracting a few. Trust me, subtracting those digits would be better. Base 6 is the best. So I'll talk more about that in another day or another video. And we also have some other fun comments, like instead of a dime, a 9 coin could be a nime. And about base 2 and base 16 and other things. So thank you all for leaving cool comments. In this stream, I probably before a huge amount of time will wrap this up. Let's quickly go back to just some of the random fun facts that, where was that? Some of the random fun facts, I'll find it, that Wikipedia had about the number 3 listed. And we're not going to go through all of them. And in fact, some of the ones I skip, I like, but I'm already going to talk about in my official intro presentation for grade -3. This is sort of like a live stream little presentation, but the official episode to introduce grade -3. Some of the ones I skip right now, I might talk about then. But some other bonus facts that may not necessarily get there is that 3 is unique as a prime, meaning that in base 10 it is here. And in base 10, its period length is 1. And that is the only prime that its reciprocal repeats just a single digit, which is what the period of length 1 means, a single digit going on forever. So that makes it a unique prime in base 10. And it also is other types of prime. As we know, twin primes are 2 apart. It is one of those. Cousin primes are a nickname for ones that differ by 4. Y'all know what differ by 6 is? Not joking. They're called, and maybe I wouldn't always use even, it's not really swearing or anything, but maybe it's language I wouldn't always use in a video if it wasn't a proper term. But it's a completely proper term. They're called sexy primes, or when they're 6 apart. The only reason we don't see that here is that 3 is not a sexy prime. Sorry, 3. You're a cousin prime and a twin prime, but you're not sexy. Now, this is funny, like all the properties, they're all these numerical ones, and then just in the mix, right in the middle, they put a triangle's made of 3 sides. Oh no, they say more about the triangle. This should just have a paragraph break right there. But okay, so they note triangles. Here's some more things about those. Smallest non-self-intersecting polygon, only polygon to not have proper diagonals. As I mentioned, quick estimates of approximations of some classic constants. And these are the ones I mentioned will come up in main episodes this grade. Mersenne primes coming soon, Fermat primes coming a little later. Good old triangular numbers. Now here's a great one. Gauss, the mathematician, proved that every integer is the sum of at most 3 triangular numbers. Now this connects to a pattern with square numbers and pentagonal numbers and so on, and that will show up in our Figurate numbers episode, but I wish they had put it as the reference right here, because there's this great little image of, where's the image of his discovery of that? Let me find it. He was so excited. So the expression eureka is sort of like, I've discovered it or something, I guess. It can be used different ways. But Gauss, he, is this the actual page? I think this is the actual page. Oh man, now it's hard to find. Okay, well, he drew these, triangles. Triangle plus triangle plus triangle equals so-and-so. Eureka! And he kind of just drew it with little triangles. Like I can imagine myself doing like 3 triangle numbers equals any number. Meaning at most 3, but we could also define that as 3, but we're allowing 0. Like exactly 3 of them. Sometimes we put zeros. And this one, I discussed briefly, only prime 1 less than a square. Trisection of an angle. That will come up when we talk about geometric constructions. It's one of the simpler, impossible things to do with a straight edge and compass. Trisecting an angle. Now, we noted that 3 is the number of non-collinear points that if you want them to all be on a shape, can define the shape for a circle, but it's also true for a plane in more than 2-dimensional space, if you want to define a particular plane of it, and a parabola. There are only 3 of this type of magic square, and that's actually not a great fact about magic squares to share about them, because there's a lot of other facts about magic squares that are all about 3x3 magic squares. We have some notes about platonic solids and polytope groups, and this was interesting. This is sort of like the cultural thing we were discussing a minute ago. It says there's some evidence to suggest that early man may have used counting systems which consisted of 1, 2, 3, and thereafter many. Maybe next grade will be in grade negative many. I don't know. To describe counting limits. Oh, that's going to be the big question after grade negative 5. When I write out grade negative 6, do I write it in base 6 or base 10? I might have to write it in base 6. It might look like it jumped to grade negative 10, but it's actually negative 6. Okay, I'll have to make that decision in grade negative 5, how we're going to write grade negative 6. But anyway, we got 1, 2, 3, many in some. And I would guess that some even simpler ones just went from 1 to many. Now, crows are something I'll talk about in an episode. They've studied how many a crow can count. And you can do that some ways by, like, you have something the crow wants to eat inside somewhere. Some go in, some go out. When is the crow confused about how many are left in there? Or when does the crow know, like, okay, 3 went in, 3 came out, there's none left. Maybe if you put 6 in and take 6 out, the crow's like, are there still any in there? Or other things like that that can give you clues about how many a crow counts. And crows, I think currently it's, we don't know that much about this field of science, but current beliefs, I think, are that crows can count up to about 4 or 5. Also, apparently, crows count 0 as a number. They recognize 0. So these are based on some tests. There need to be more tests run on crows. Maybe I need to start running some tests because crows live in this neighborhood. In fact, I have some neighbors, not the ones that share this yard, but a bit down, elsewhere on the block, some neighbors who feed crows. And so the crows are happy and they come. So maybe I should study the crows more. But anyway, 1, 2, 3 many shows how 3 was distinct enough to these old tribes to not fall in the many category, that 3 had distinct reasons to use in the language without just converting it into many. And 3 is more linked with 2 than a lot of people remember, because if you have one thing and another thing twice as big as it, this is 1/3 of the total. This is 2/3 of the total. So comparatively to each other, 2 is comparatively to the whole 3s. So 2s and 3s are super linked. And 3s, it makes sense to maybe show up in aspects of nature. You see them in a lot of plants. You see them on a lot of insects. They are on parts of our body. You have 2 parents and 1 kid. So a lot of cultures do things like morning, afternoon, night, or things like that to divide up the day. So a lot of 3s culturally, and it's interesting that they have observed some cultures that 3 was sort of the last distinct number that they found necessary before going to many. Now, and sometimes people feel confused, like, why would they stop at that? Wouldn't they have thought about numbers more? But we think about and use language for the things that are useful to us. In the future, there will be plenty of things that they're like, why didn't they have a word for that? But it just wasn't something incorporated in our life. And in the way people used to communicate, it was less numerical at times in very early evolution of humans. And, some of the earliest documented times we had to write numbers were like a grain seller who had a bunch of grain and some guy owed him money or something. Like, I'm going to borrow some grain. Okay, let's scratch off some things on the wall for how many buckets of grain you borrowed or stuff like that. So we also have a comment from Inspirator that a nickname for base 120 is centovigesimal. Nice. I like the number 120's nickname in history. It's historically known as the long hundred, and 120, what a number. 120 is a beautiful, magnificent number. Too large for us to use as our base number, but ooh boy, that number. It is also both triangular and a factorial. Kind of like 3. 3 is extra special because it's, kind of like 6 more so. 6 is 3 factorial and the third triangular number. 120 is not the same number as triangle and factorial, but it's some number is triangle and another number is factorial, in specific 5 factorial. And it's one of the only ones along with 3 that has those traits. And then you got like 36, which is a triangular square, but also is the square of another triangular number. Some of these numbers have so many magnificent traits, but 120 will certainly see more, that good old long hundred, because remember when we were on superior highly composite numbers a bit ago? Well, 120 is an all-star there as well. Now, Wade was wondering what if each alien digit was a unique pheromone imprint, like they communicated like bees by making a different smell or something. Totally possible that they don't write stuff down to communicate. And if you don't write stuff, you're not going to use the same type of numerals. And so who knows how you'd describe things. Perhaps there are even aliens that don't even care about whole numbers. They care about spectrums of things. They really care about pi and e describing growth rates, but 3 doesn't show up to them. So who knows, The cool thing about math, though, is that if there are any aliens out there who have a lot of free time and they evolve and they have free time to ponder, okay, what's beyond what we need math for? Because we can think about what are further extensions that maybe in the future we'll need. Maybe they'll just tell us interesting facts. But like prime numbers were researched just because they were interesting and then became very applicable in different ways throughout history. But perhaps what I like about math is that although aliens would begin math very differently than us, if they had enough free time to get to that state of pondering what else exists as possibilities, I think they would come to some of the same conclusions as humans. I think they would still recognize like these equations. Maybe they would write them different, but I think they would have, if that aliens would somehow get to the point of part of their mathematical world contains, under this given system, adding the first three, doing this thing called adding to the first, what is called 3 amount of things, is the same as doing this thing called multiplying to the first, what is called 3 of those things. Maybe they would be an alternate weird system to them, sort of like the quaternions to us or something, or a negative, beyond a negative base, but something that's, doesn't show up as obviously in nature, but is mathematically interesting. But I think they would come to some of the same conclusions because I think math is somewhat universal. They would have a very different origin and probably a very different way of writing it, different base such like that, if they even used a positional numeral system. And the positional numeral system, I will say, it maximizes certain types of efficiency where it's not illogical that if there are a bunch of aliens out there who do math, that some of them might use positional numeral systems based on powers of a number. There are reasons why that's really efficient and good to represent numbers. So, although some aliens would be very different with their math than us, I think the universe is pretty big. I don't know necessarily if any of these aliens are close enough to us to contact us or for us to contact them, but somewhere in the universe, I feel like there's some aliens somewhere that's using base 6, or they're probably not writing on paper the digits, but have something similar to base 6 for what they do. Somewhere out there in the universe. Oh, it's me. I'm that alien. No, kind of true. Anyway, I kind of wanted to do more math on my channels just in base 6, but I was like, this will kill the channels if there's some videos that are just not understandable unless you know base 6. And in base 10, every equation I'm writing looks wrong. So, yeah, we got to still write in base 10. You got to work with your society if you want to communicate ideas functionally. And there are some more notes from Inspirator in the chat about some other cool traits about 120, some notes from Chan about crows, and some other cool thoughts. So thank you all for those comments. I do think before too long, I am going to wrap up this stream. I wanted to share some fun facts about 3, and I just haven't done anything on this channel in a minute, so I wanted to be like, well, first of all, make sure you've seen that grade -2 finale if you want a deep dive into my past year and putting together the past grade and some secrets and such. That's linked in the description. And I also wanted to let you folks know that we are ready for a very big clock. No, a very big beginning to grade -3. I'm not showing that part of the classroom because it's in progress, and there are new clocks that I'm not showing yet until the official intro, and there's going to be new whiteboards and more. Now, another stream I might do soon is testing some old classroom supplies to see if it's still functional at all or if it's dead for good. For example, I have a lot of bubble fluid, and my bubble machine broke, so there's other ways to make bubbles. So does the bubble fluid still work? What else still does or doesn't work around here? But as usual, I'll say if anyone has any particular things they enjoy seeing in the live streams, let me know, because these are always a bit more casual. They'll have a topic, but they skew toward, I'm more willing to do a random live stream about what a couple people are curious about or interested in. So if you are interested in my live streams when we do graphs, when I've created music of different sorts, when I discuss stories from my life or show the nature around here, when we go on the OEIS or other mathematical websites like that. If any of those topics are your favorite for our casual live streams, let me know, and we will do more of those soon. I do have a few bonus videos as well that I'm going to cut out of some extra things from grade -2. So there'll be a couple bonus videos probably that will begin with me looking more like this, doing a little intro, and then going to some footage of when I had the longer hair, because there is still a bit of footage that didn't end up released yet. Similarly, there may be a few shorts more that come out where I still have long hair. So be warned, it's not 100% chronological how I release things here. And so there'll be a little bit of glitching in the haircut for a second, sort of like we're switching channels and it glitches a little bit first. So that's about all I had planned for today's live stream, but thank you all so much for joining me either live or if you are watching this in the future. Check the video description if you do want to get that link to the finale episode of last grade, or to things like the Discord where Combo Lords chat, or if you want to be super helpful helping me set up for grade -3 and get a little bit of bonus content and your name in some of my credits. Check out the Patreon, or there's also YouTube memberships on this channel. Anyone who's able to do that does help me have a higher scale, better level of presentation for all the cool topics that I want to present this grade, and will help me on my plans to teach all of the cool, magnificent things that I know to you folks, and learn more magnificent things to teach. So, thank you all for watching, or for especially to the people who are tuned into those different things I mentioned. I'll be back on this channel in, I'm not sure exactly which form next. We'll see whether the next one's a short or bonus video or live stream, but I'm mostly working on finishing up that official intro episode, and then some of the early episodes of the main topics grade -3 will include a Pascal's Triangle episode before too long, as well as an episode about perfect numbers and the link to the new prime with perfect numbers, the new largest known prime, and the lesser talked about new largest known perfect number. And those are a couple of the early ones, along with many topics that I have with this grade leaning back toward math, as usual, where there's going to be many number theory topics. Also, a few of the topics that I have brainstorms for this grade include some game theory things, analyzing some more games and the inner workings of the strategy or mathematics or things like that. And for example, there might be an episode about grid puzzles, and there may be an episode about logic puzzles, such as these people always lie and these people always tell the truth, or something. I'm studying the best cards. And just about design of games in general and what makes a game. I think people will find that interesting, what I've deduced about the worst cards to ever exist in Magic. And so those are a few of the game ones. Another topic that, and then of course, apart from the math and the games, there are also sometimes snack breaks. I'm not going to drop those. I like occasionally having a weird little botany type of snack break or whatever. But one new topic that will come in grade -3 that we haven't done yet as main episodes will be music, because I know a lot about music and actually used to be a music teacher for a while before combo class. So actually overlapping with the beginning of making combo class a little. And so there will be episodes on, at the very least, an episode about my theory of the mathematics behind piano chords and how I taught that to students. And for anyone who already likes math, you're going to have a big head start on whether or not you ever think you'll play piano. In 10 minutes, I can teach you every major chord and every minor chord with a pattern. So there will be some music episodes like that. Perhaps the episode will also, or the grade will also include one about scales, or perhaps it will include ones that are focused on how these translate to other instruments like guitar. Perhaps at some point there will be ones about digital beat making, about rhymes, and about various musical topics like that. So that's something that I want to start incorporating beginning with grade -3, and it's a good fit because a lot of the chords I'm going to teach require 3 notes. triads. So, thank you to everybody joining. Like I said, I am actually going to quit now. I'm bad with goodbyes, so I keep ranting because I'm bad with goodbyes, and it's fun to hang out with people a bit longer. So I like hanging out with you digital folks, even if it's more of me ranting at the camera and reading a few comments and imagining all the folks who might be watching this. Hopefully some of you folks watching this are aliens in the distant future. And so extra shout out to those folks. But okay, everybody, you don't have to be an alien in the future. Thank you a lot. I love you. And I'm going to log off until next time.